In this video, I will show you how to complete the last part of the project, question 6, which is on simple linear regression. The idea here is we want to see if there is a linear relationship or best estimating line for data between two quantitative variables. So we're going to examine total cholesterol and systolic blood pressure. In the actual assessment, you will examine total cholesterol and BMI. So the first thing that we want to do is highlight our data here. So I'm going to highlight the labels and I'm going to scroll down to the bottom of the data. And I'm going to hold the Shift key. And highlight those two columns. So now that I have those columns highlighted, I am going to go to the Insert menu, Recommended Charts, and then this very first one in the upper left is the scatter plot. That's already selected. I'm going to click OK. And so here is our scatter plot. This is on the x-axis, this is total cholesterol value, and on the y-axis is systolic blood pressure. So we're seeing that this data is clustered up in this area, and it doesn't really look like there's a line that would fit this data. So if there were a line, it looks like it might go in this area here, but we see that there's a lot of points that are really far off of this line. So if there is a linear relationship here, it's probably pretty weak. So how do we measure a linear relationship? Well, that's the linear regression. So I'll move this chart out of the way. That's just giving us an idea of whether there might or might not be a linear relationship. And now we want to go to the Data tab, to Data Analysis, and then we want to scroll down and hit Regression. Click OK. And then we're going to input in this dialog box our Y range. So let's use total cholesterol as the Y, and that's stated here, and systolic as the X. So total cholesterol, I'm going to highlight the data label, and I'm going to scroll all the way down to the bottom. Hold the Shift key and hit that last value of 439 in total cholesterol column. So that's my Y range. Now we'll do the same for the X range. So we're going to come up here to the top. We'll click systolic blood pressure. I'm going to scroll down to the bottom and click the very last value in that column while holding the Shift key. So that's the 145. So there's our X and Y input. We're going to click the labels because we did include the labels as the first entry here. And we're going to select an output range. So click on Output Range, put your cursor inside the dialog box, and let's just pick a convenient place for the upper left-hand corner of our table. So maybe right there, and press OK. So here's our output. We want to now interpret this. So the first thing we're going to look at here is this multiple R. So the multiple R is called the coefficient of correlation, and it tells how strong the linear relationship is. So if your R value here is close to 0, it indicates little or no linear relationship. So that would be like 0.1, 0.2, 0.3. If R is close to 1, like 0.8, 0.9, then it's a very strong linear relationship. So we see our R value is close to 0, 0.21. So we would say that here there is little to no linear relationship, is how we would interpret that. The other thing we want to look at is the significance level of the test here. So the significance level is the same as the p-value for the test. And what we see here is this is 7.4 times 10 to the negative 43 power. So that is a very small number. let's see, it's put a caret in there. So that's what that means, 7.4 times 10 to the negative 43. That is a very small number. It is certainly less than 0.05, which is usually your accepted significance level. So that means that this regression is significant. So it's not by chance, our result's not by chance, but it's also not a strong linear relationship. And then the last thing that we're going to look at are the coefficients down here. So we've got two coefficients, intercept and systolic blood pressure is our x. So remember that a line has general form y equals mx plus b, where y is the dependent variable, m is the slope, x is the independent variable, and b is the y-intercept. So for our line, our equation is going to be y equals, and then our slope is right here. Let's round to 2 decimal places. So let's do 0.43x. And then here's our y-intercept, plus 180.3. I had a times in there. I want a plus. So, and whoops, I forgot our x. There we go. So y equals 0.43x plus 180.3 is our regression equation. Or you could also write this as our dependent was total cholesterol. So total cholesterol level will equal 0.43 times systolic blood pressure plus 180.3. So that's saying if you have a given systolic blood pressure, you can plug that value in here, multiply it by 0.43, add 180, and you'll get the predicted total cholesterol value. So that is the equation of the regression line. So this is the regression line equation. And if our model was significant here, then we would use this, this regression equation in order to predict values. So since our model is not significant, we won't be using this regression equation for any predictions. So here's how we would complete question 6 in the example. Our characteristic x value, our independent variable, is systolic blood pressure. Our regression line, y equals 0.42x plus 180.3, and was that 0.43x, I think? 0.426, yes, 0.43x. Plus 180.3. Our p-value was the 7.36 times 10 to the negative 43. Remember that scientific notation means move the decimal to the left 43 places. So that's very small. And then the r value, the coefficient of correlation, that's the multiple r, that was right here, is 0.21. And how do we interpret this? Well, the regression or best fit line to the data has equation y equals 0.43x plus 180.3, where y is total cholesterol and x is systolic blood pressure. Since our p-value is less than 0.05, the result is statistically significant. However, r is 0.21, which is close to 0, which indicates little to no linear relationship. So you will do something similar in the actual assessment. So you're going to be doing, instead of systolic blood pressure, you'll be looking at BMI, see if there's a relationship between BMI and cholesterol. Now you're probably thinking, well, we didn't study regression in the chapters, and you're right, we did not. But linear regression is something that comes up quite often in the research, so I wanted you to be aware of what those numbers are telling you, the R value and the regression line, or the best prediction line.